to day number 2 of Advent of Code. This is actually the same day for Advent of Code, mainly because I am here in Australia, where we are ahead of US Eastern Time by about 16 hours. We are having a couple of video. Okay, is that hopefully better? Not, well, we're just going to have to deal, unfortunately. All right, let's go ahead and cut over to the browser. So we are over here looking at Advent of specifically. For those of you who aren't familiar, this is a set of daily programming puzzles every day for the first 25 days of December. And they're all two-part puzzles. So you kind of get one input and you apply it to both puzzles, but the second one in each day, second subproblem of every day is a variation of the first subproblem. So with that in mind, let's go ahead and look at day 2. Okay, so Kerbal Space Program. On your way to do a gravity system on the rune. A 1202 program alarm, and the ship's computer bursts into flame. Oh no. Int code. Okay, opcodes. 99 is halt. Oh wow. We have jumped forward in difficulty a lot further than the previous years of Advent of Code. In previous years of Advent of Code, what would normally happen is you would expect to see a more slow ramp up of difficulty. However, in this case, we are actually being asked to write a virtual machine kind of on day 2. This definitely has some interesting implications for what the next 24 days are going to hold for us. So let's go ahead and get started with that. So let's read through the problem description one more time. So opcode 1 takes, okay, opcode number, it reads the values at certain positions. A position, I assume, is just any arbitrary position. Let's see. Shifting forward 4 positions. Oh dear. Not only is this operating with bytecode, this is actually also mutating the bytecode as we go. So if you're asked to change code at a given position, you're actually changing that number. That's fascinating. Okay. Yeah, so this doesn't actually have registers. This is the tape of the program itself is the tape of the program. So this is kind of like a Turing machine. Okay, that makes sense. So positions are positions. That's fine. Yes, I'm being told that my background still says they work at GCP. Yeah, I know. I'm lazy and I've lost that is unfortunate, and we're just going to have to carry on. All right, great. So with that, let's go ahead and do this. So we're going to copy day 1 to day 2 because a lot of the input mangling is still about the same. The one difference is change that. Also, instead of splitting by new lines, we're now splitting by the comma. And now we need to replace all of this body here. Okay. Just want to make sure that I've parsed my input correctly first. Okay. All Great, so that's fine. Let's see. With a capacity of length of split. Okay. So that's fine. And then we need tape of I equals n. I think something like that should do the trick. So let's edit day02.input, and we'll just grab that puzzle input. I'll just do that quietly off screen. Paste this in here. Okay, that seems fine now. Right. Don't need that. Failed to parse 0. Why did you fail to parse 0? Oh, probably because it's a new line after it. Okay, right. That's fine. Okay, so that condition doesn't apply, but we need to strip off. Okay, I think that should work. Something like that should work. -1 or -2? I think it's -2. Let's try that. Nope. Okay, so this ends in the numeral 0. Okay, I definitely do not have the number 0 on the end of this, and I ought to. Cool. I am parsing the 14, so that's just, I think I just got this wrong. Oh. Outputs. Oh. Now this actually just has the same length. Okay. Ta-da. Okay. Now my tape is working correctly, I think. Oh, and I should probably open up my stream chat on my phone. Sorry for folks who are typing in the stream chat. Also, thanks to Microsoft who are sponsoring me with this space at the moment. Okay, great. Let's go back to the problem description and let's have a look at what happens in the tape. So we need to maintain a current position, and then we need to use the current position to read the current opcode and then decide what to do with it. Move to the next one by stepping forward 4 positions. Okay. Great. I think I understand this problem, so let's go ahead and implement. Be kind, rewind. Thank you, Eric. Okay. So let's go ahead and do this now. So now I have this. So let's just set a debug flag really fast because I don't like deleting code like this. Okay. Print bug info as we go along. Okay, cool. So now we need the current offset is going to be initially 0. Well, forever. If is less than 0. Actually, that's impossible because we always step forward. But if offset is greater than or equal to the length of tape, this shouldn't happen. Ran off end of tape. Okay. Okay. If offset If tape at offset is 99, then we need to fulfill the puzzle criterion, which is to print what's left at position 0. Okay. Okay. Otherwise, okay. Failed to match opcode. Just make sure I'm projecting the correct thing, because that's now a problem I have to worry about with late stream. Yeah, I'm projecting the correct window. Okay. Fine. So, my two possible opcodes are, if I have opcode 1, then it's add, then it is, otherwise opcode 2 is multiply. Okay. Cool. Offset plus 1. Okay. Really fast, actually. Okay. A, B. What on earth did I do here? Yeah, that's fine. Operand B, and okay. Tape at offset plus 3. A times B. Run Go format. That looks fine. Okay. So let's try that. Why did it fail to match offset 99? Oh, righto. All good. Okay. Cool. I think that makes sense. That makes me really suspicious, because the original value is still oh. Yeah. My bad. There we go. I was really suspicious about that. This is why we check things, kids. There we go. Good. Okay, now that feels better. I entirely believe this result, so let's go ahead and plug it in. See what happens. That is not correct. Okay, let's go ahead and run some sample inputs in order to understand what happened here. So, to simple. So let's give that as an input. And let's to simple. Okay, that returned 30. Yeah, that's fine. That's correct. Oh, whoops. Oopsie. I failed to read the problem description. you have to first, thank you, Eric, you have to first, before running the program, replace position 1 with the value 12 and replace the position 2 with the value 2. Okay, so that was my mistake. So everything else was fine. I just failed to comprehend the problem. So replace position 1 with the value 12, replace position 2. Okay. I suspect there is going to be this is my spidey senses telling me this is going to be the gimmick. Tape index 0 becomes 12. Position 1. Wait. What does it mean by position 1? Oh, there are positions 0, 1, 2, and 3. Okay, just making sure we're still 0 indexed. Tape of 2 is the value 2. All right, so that's, why is that still 136? That seems really, really unlikely. Huh. Oh, whoopsie. I see my problem. These are all input positions. Okay. Okay, now I believe this answer a lot more. Okay, so let's try that. That is correct. Good. Okay. Now the second half. Keep this problem nearby. You'll probably use it again. I wonder why. So instruction pointer, yep. Instruction pointer increases by the Yep. Okay. Great. I understand what we're supposed to be doing here. Lovely. The implications have been stated outright in the description of part 2. Okay, so let's go do this. And hey, by the way, at some point it would be convenient to, for instance, instead of debug outputting things as we go along, wouldn't it be convenient if we sent these outputs to Honeycomb? Thinking face. Okay. Indeed. Okay. So let's see. Okay. I don't need this. If debug. Okay. Okay. This should never happen, so I'm going to leave this as is. This should also never happen. We also know at the moment that, actually, I know I'm going to need this. So okay. Very, very well. Let us now do this. Okay. So let's just make sure I haven't broken it first. Just make sure that this works first. Let's see, what's the syntax of this? The syntax of this is Golang copy, copies from source to destination, but it does dest, comma, source. Okay. Okay, so let's just make sure this continues to work. Which line was that? Line 49. Oh, what have I messed up? Come on. I know I have made a ridiculously silly error somewhere in here. Oh, righto. There we go. Okay, that yields the same result. That does as we expect. So you're being asked to find which pair of inputs produces a certain result. That looks like it's a relatively fixed result. Okay, that's fine. This is only a problem search of 100 and 100 possible input parameters. So this feels normal. Which inputs are possible? You just double check that the set of possible inputs to the program will be between 0 and 99 inclusive. Okay, great. And it's the noun and the verb. Okay, for verb 100. Okay. Oops. Okay. If working tape accepted, then okay. All right, and we need noun, verb, and then 100 times noun plus verb. Okay. And if we reach the end of this, then we know we're in trouble. Failed to find solution. Okay. Noun. Let's make sure that that matches what I expect. Yep, at positions 1 and 2, noun and verb. Okay. Feel okay about this. Let's make sure it's valid. Go. Okay, that seems fine. So let's go ahead and plug this in. And that is correct. So that is data number 2. Before I terminate my stream for today, what I'm going to do is, because I've been signaled to reuse this, I'm going to actually make a Go module. So you can watch me stumble my way through doing that. I think this has no imports. Oops. Why is there? Oh. Okay. So we need. Why don't we keep the parsing code around for now? The parsing code seems generically useful. I don't need this. I don't need this. I don't need this. The flags will be dealt with in my main function. So let's see. So I need format. I need IOUtil. Okay. So that needs to be a publicly exported module. And this is going to return a int array. Okay, that's fine. Okay, great. That seems okay. And then over here, that needs, actually, let's do it this way. Just define that way. That way I can do something slightly more magical. Okay. So that seems fine. Okay. Okay, that seems fine now. Before I do this, actually, to solution. And now let's go ahead and libraryify it. I have no idea how this is actually going to work. Okay. I think that should work. Oh, I need like that. Okay. And now that seems fine. So okay, that's all right. I think something like that should do the trick. Okay. Okay, we've now libraryfied this enough. Let's see this. Really? Does that work? There's no way this should work. Now I get to fight Go modules. What's this called? This thing is called a int computer, I think. Int code. How does that work? Okay. Oh. R. Okay. Okay, this is Go 113. Fine. We're doing this the hard way. We're absolutely doing this the hard way. Okay. Yep. Okay. Yep, that's fine. All right. How do I do this? I need a Go mod file. It's a little annoying. Quick start for go.mod. Oh, I need to go mod init. Gray. 19. All right, something like this should work. Will that work? I bet this should just work now. Let's see. Ah, yes. Okay. Great. That seems fine. Oh, that's fine. Don't need that anymore. So 8 and 9. Great. Cool. Read input. Okay. Let's burn down the rest of these. Oh, right. Okay, and in 22. Will this just naturally work? Yep, it does. Cool. Ah, oh God. Oh, I hate Git. No, how do I? Oh, rm dash dash cached. Is that it? There we go. Okay. Yeah. Okay. There we go. That's better. Let's just format that. Format that. Yes, I know there's a more efficient way. Okay. Okay, that is my day 2. Thanks for watching, folks, and hope you have a good one. And I will probably wind up seeing you all in either in 24 hours or sometime Wednesday morning Australian time, depending upon what I feel like doing and where I am. So